Are you failing science again?
No.
There is no way that you're passing.
How would you know? I can do really cool things too, you know.
Because you've never done better than me in science.
Are you failing science?
No, you can't prove anything. I just figured my grade was a little less than ideal. So we should study together. 2 birds, 1 stone. Listen, Davinia is passing with a 102.37%.
102.3. How is that even? Why do you know this?
Shh, hush. I figured out how to get into her Infinite Campus account.
You crazy person, you.
Forget it. Look, I'm going to call her and ask if she can help us. I heard she's secretly really nice.
Isn't she a mute?
Hi, Sanuka. Davinia speaking.
How do you know my name? Hi, Davinia. Long time no... Sorry, creep. What? Lataku hasn't been doing great on her grades. We were wondering if you could help us understand what's going on in science class?
Photosynthesis. That's always a fun one, isn't it? Is Lataku trying to rage quit school again?
That was one time! No, she's...
Oh, right. You've got a 48%, don't you?
She what? How do you know? How do you know? Can you help us out or not?
Sure thing. Just give me a second.
Okay, she's on her way now.
Let's do this.
Okay.
We are heterotrophs, meaning we eat other things for food. But what about autotrophs, like trees and flowers? Well, they're like their own personal chefs and create their own food using water, carbon dioxide, and sunlight. They use a process called photosynthesis to transform these ingredients into glucose, their food, but also expel oxygen in the process. This is important because we need oxygen to live.
Why do we need oxygen again?
To breathe.
I think the air does us just fine. Thank you.
The air is oxygen. We breathe the oxygen.
That's why plants are so important to our ecosystem. Anyways, the process of creating oxygen and glucose can be split up into 2 smaller processes, the light-dependent reactions and the Calvin cycle. Both of these processes take place in the chloroplast of the plant cell. The light-dependent reactions are specifically in the thylakoids. In the membrane of the thylakoid, there are 2 photosystems. To start, photosystem 2 receives light energy.
Why are you starting with the second one and not the first one?
Oh, that's because they were named in order of discovery, not the order of process. So photosystem 1 was discovered before photosystem 2, despite photosystem 2 coming first in the process.
That's really dumb.
Yeah, it's like they wanted us to fail.
I didn't make the rules. Moving on. The light energy molecules energize the electrons in photosystem 2, causing them to move onto the electron transport chain. On the inside of the thylakoid, water molecules are being split into hydrogen ions, electrons, and oxygen molecules. The oxygen is released here for heterotrophs like us to breathe. The electrons from this replace the missing electrons in photosystem 2. The electrons on the transport chain move along into photosystem 1, but on their way there, they release energy and create a hydrogen ion gradient. Hydrogen ions outside of the thylakoid are then pumped inside. The high concentration of hydrogen ions inside of the thylakoid causes them to move through an ATP synthase. The energy produced from this is enough to add to this phosphate ADP, creating ATP. The electrons left in photosystem 1 are released outside of the thylakoid, where they are used with a hydrogen molecule to turn NADP plus into NADPH. That is the hardest part, I swear. Now that we know where NADPH and ATP come from, we can move on to the Calvin cycle. In the Calvin cycle, carbon dioxide is turned into glucose. This all takes place in the stroma of the chloroplast and can be sectioned off into 3 parts: create, break, and recycle. In create, carbon dioxide molecules are attached to the RuBP molecules using Rubisco enzymes. This creates an unstable 6-carbon molecule that will almost immediately move into the break section by breaking it half into a 3-carbon molecule. We call this 3GP. Now the NADPH and ATP come in to break the 3GP down into G3P with the energy in their electrons. The remaining NADPH, now NADP+, returns to the thylakoid to be recycled. One of the G3P stays behind to be made into glucose, but the rest moves on to the recycle section to be broken down into RuBP by ATP so the cycle can repeat again. This cycle has to repeat many times because it cannot produce the full glucose molecule on its first go. It takes several rotations to do so. So as you can see, the Calvin cycle cannot function without the NADPH and ATP produced from the light-dependent reactions. To summarize, water and sunlight are used in the light-dependent reactions to create ATP, NADPH, and oxygen. The ATP and NADPH move on to the Calvin cycle to be used as fuel to make G3P in order to create glucose, whereas the oxygen is released. Now it's a review time. Why is oxygen released?
It is expelled as a waste product when the water molecules are broken down in the light-dependent reactions.
Why are the light-dependent reactions important?
They produce NADPH and ATP.
What are NADPH and ATP used for?
They are used as energy to fuel the Calvin cycle.
What is the Calvin cycle used for?
Food! It creates glucose for the plant.
I got that one first. That was me. That was all me. I did that.
Okay, Lataku, what is the name of the whole process?
Yeah, Lataku. What is it?
This is my moment. This is what I have lived for. This is the time.
Hey, you guys want some pizza?
Is pizza relevant to photosynthesis?
No.
I want pizza. Yeah, pizza would be kind of nice.
Pizza would be good.
I wouldn't mind that. Yeah, let's go.
Thank you.
Oh, almost forgot. Oops.
I figured it out. I figured it out how to get into infinite campus. Shh, hush. I figured it out. I figured it out how to get into infinite campus. Da Vinci.
The electrons on the transport chain move into hydrogen ion used with a hydrogen into the break section by breaking in.
My grade wasn't ideal. So, 2 birds, 1 stone.
The energy produced.
Lily! Oh my god!
So, anyways,
Because you've never gotten a higher grade than me.
Really? I've never passed science. This is my 6th year. Why are you still here?
Are you failing science class again?
No.
How are you? Tell me how you're passing.
I just am.
No,
I just am.
wait, do it again.
ASMR.